Welcome back to this exciting series with a real deadline. To change the control arm bushing, a press is needed to extract the old bushing and then insert a new one. Exactly how much force is needed I do not know, but I once had to do this in a cheap hardware store grade vise, and I bent the sled of the vise trying to get the old bushings out. So let's say a fair bit. Now I have access to a lathe and a mill and an angle grinder and all kinds of other stuff, so I will make my own press using mostly the materials available in my garage. I had been planning to make this for a while, albeit in less of a hurry, so I already have a suitable trapezoidal spindle and a matching nut, which I ordered some time ago. First, I am making a sketch of the parts I will probably need. The press will consist of 2 thick cold rolled steel plates held together by 3 rods. The rods will be just M12 threaded rods if I can find any, otherwise I will use available round stock and cut a thread on either end. The trapezoidal nut sits in the top plate, spindle goes through it. The spindle has to have a driving piece of some kind on the back end to connect with the ratchet and socket, and a nose at the front to which the press dies are attached. The bottom plate has a hole large enough for a bushing to be ejected through it if the setup ends up working that way around. First, I have to cut the steel plates with an angle grinder. I don't have a workbench with a vise because all my workbenches are taken up by my mill and my lathe. So I figured, screw it. To a piece of wood, I mean. Then, kneeling on the piece of wood for extra safety, don't do this at home, I can cut the plates to rough dimensions. Do not do this at home. I am squaring them up on the mill and then cutting them to final outer dimensions. Next, I'm marking up the holes, center punching them and drilling them out. The square trapezoidal nut will be sitting in a shallow milled out pocket in the front plate to make sure it does not spin under load. So after drawing the lines for the pocket on the top plate by abusing my poor calipers and touching up the end mill I had used on the wheel bolts 2 days ago with a diamond horn, I am cutting the nut its shallow grave. After deburring the edges, I used 2 M12 bolts to hold both plates together, and after some trial and error, I managed to set the whole package up in the lathe with the hole for the press spindle lined up with my turning axis. Next, I'm using a boring bar, to increase the diameter of the central bore to 30 mm in both plates. The front plate only needs a 30 mm hole, so at this point it is finished lathe-wise. I removed the M12 screws holding the plates together and then put the back plate back in the chuck, as it needs to be bored up to 57 mm. After bringing it up to final dimension, I am chamfering both sides of the hole using my boring bar set up at an eyeballed 45 degrees. Next, the trapezoidal nut needs to be turned down at one end, so it will seat into the 30 mm hole in the front plate. Because it is a square piece without a smooth central bore, it is difficult to dial it in on the independent forejaw. Because the centricity of the press spindle is not critical to the micrometer, I am using the old corner locating trick to dial it in by eye, which can produce pretty decent results, if patience is available and the lighting is right. When you want to know whether you chucked up the square work precisely, after taking off the corners you can see basically even small deviations just by eye. So this looks good enough. After getting the nut to fit snugly into the front plate, I am back at the mill to drill a hole for an M3 grub screw to hold the nut in place. The actual thread will only be cut into the bottom 5 or 6 mm of the hole, while the rest of the hole is drilled out large enough for the M3 tabs to reach in. After having broken ungodly amounts of M3 tabs designed to cut a thread in one go during my lengthy career as a hack, I have finally invested in a set of partial cutters. Each of these only cuts a portion of the thread profile depth, so the cutting forces are lower and the risk of snapping the little buggers is significantly decreased. To know which order they have to be used in, they are helpfully marked. One has no lines on the circumference, the other one has one line, and the last one has 2 lines. And if you now think you can deduce from pure logic which order they have to be used in, I am sorry to tell you that you are most likely wrong, at least if your logic works the same as mine. 1 line is the first, 2 lines is the second cutter, and the last one is the one with no lines, and that one cuts the final thread. The thread being done, I deburred the pocket and the central hole carefully and then inserted the square nut. Not carefully, with a hammer. With the grub screw fastened, the front plate assembly is complete. The tip of the spindle will need something hard and wear resistant to act as an interface between spindle and whatever press piece I attach to it. I want to make the thrust bearing out of something a bit tougher than mild steel, so I am sacrificing this piece of round stock, which I think is some kind of tooly steel, probably. The reason I refer to this as a sacrifice is that this was part of an exercise during an internship many years ago to make the end caps of this cylinder both light gap perfectly square to the cylinder wall as well as parallel to each other and flat. It's more work than you might expect if you have just a coarse and a fine file and a hair angle to do it. To be fair, I also had lights and a workbench, but you know. Whatever it is quite a tough material to turn, but I managed to get it into shape. The back end has a flat bottom hole for receiving the trapezoidal screw, and the front has a 12mm nose to center the press pieces. Then I took the round stock I wanted to use for the connecting rods between the two plates. The only fitting stock I could find off the bat is something measuring around 13mm, I'm guessing ½ inch nominal. I need to cut an M12 thread on each end of the 3 rods, so here you see me sensibly turning all the ends down to 11mm and then cutting a very shallow thread into them, because that's how I roll when I don't sleep. On the bright side, I got a free adrenaline rush and I tried assembling it anyway. But the M12 nuts don't like it if the thread is cut on an 11mm rod, if you didn't know, and they easily turn over. After pulling my hair out for a while, I found an M12 threaded rod in some hidden cache that I had forgotten about, which was just long enough to do the trick. And so after cutting that to length, I could finally proceed to assemble the apparatus. I also found one more piece of this ½ inch rod that I could use for one of the 3 rods of the press, because I only had enough M12 threaded rod for 2 of them. As you can see, the grub screw I intended to fix the trapezoidal nut with doesn't really do the job. I don't know why. Last but not least, I scrounged up some random steel bits to turn into press pieces. The usual 2 for extracting, 2 for inserting. And this is how I fixed the driving nut onto the spindle. I just soldered it on. First I wanted to pin it, but I was worried about weakening the spindle itself by cross-drilling it, so welding wasn't really an option. And I thought with a big enough surface, solder might just do the trick, because solder is actually quite strong. It's just that it's not typically used for structural connections, because usually there are better alternatives, but in this case I figured give it a try, and it worked very well. Good thing I have this long-handled ratchet, because the one I normally use didn't quite provide me with enough leverage to press the bushings out. And here we go. Looking good. Now we'll insert the new bushing. And first clean up the hole a little bit, because you don't want to have a dirty hole. Bushing will be there for a while. It's a bit fiddly because the press pieces don't really stick together. I should have added some sort of O-ring or something on the nose of the spindle, so it kind of keeps the pieces stuck there. I might still do that later. As you can see, it's going in fairly smoothly. I will also probably add a handle onto the press frame at some point, because holding onto it is not that easy, but it works. Here's the second bushing coming out. If you couldn't buy this thing for probably less than 50 euros, I'd say pretty cool thing to make it yourself. And here it is, works like a charm. So I exchanged the damn bushings finally. I tried to do it under the car without removing the control arm from the steering knuckle, but that did not work so well because the press is heavy as, and because there was a wrong bushing in the other control arm, which I think belongs in the subframe of a car with M10 subframe bolts, minus M12. The subframe bush is similar enough to the correct one, but it has slightly different dimensions on the outer rim, so my press pieces were closing in on the metal of the arm instead of the bushing. TLDR, I had to make yet another small press piece to add to the stack, but at least it wasn't my own fuck up for a change. After working most of 3 days, interrupted only by the necessities of the physical form, such as rapid calorie stuffing and short naps, I managed to get the car back together. It ended up going the distance and returning using merely a liter of motor oil. And fuel, of course. I did not end up needing the approximately 200 kilos worth of supplies I took along, which included but were not limited to 4 axle stands, 2 jacks, a spare starter battery, 2 spare wheels, all my half-inch Proxxon industrial tooling, my famous quarter-inch toolkit, 6 liters of water, box of hose clamps, a multimeter, zip ties, a tire inflating compressor. I think you get the gist. The ride was comfortable, with cruising speeds between 130 and 180 kilometers per hour. Fuel consumption was around 11 to 12 liters on 100 kilometers, thanks to the slush box, but I wasn't exactly being gentle with it either. My passenger was sleeping most of the way on the back seat, belted in of course, proving once again what a great family touring vehicle the B4 Avant was and still is to this day. Provided you get a manual, because that uses 3 liters less under the same conditions. But hey, you don't look an 850 euro herd of 115 cranky horses in the mouth. There will be more car stuff coming, because this car is just such a gold mine of faults and neglect. But if you hate cars, don't fret. There are other channels on YouTube covering every recreational kink you could possibly have within reason. And I will make non-car related videos as soon as I find time for doing stuff that is less urgent and maybe more fun than freezing my butt off lying in the driveway at night. So thanks for watching. If you have any constructive criticism, please write me a comment and I will see what I can do to improve the overall experience. Anyway, peace, love and rock and roll.